This video is the second in a set and will provide the most value when viewed after seeing Primary Controls Part 1, which gives a review of basic electrical safety and an overview of primary control functions. It is intended to serve as a review for experienced service technicians and as a part of an instructor-supervised session for students participating in an oil heat training program. First-generation CAD cell primary controls.
During the early 1970s, our industry witnessed the introduction of CAD cell primary controls. Commonly called CAD cell relays, they use a light-sensitive cadmium-based semiconductor to sense the presence or absence of flame. While the basic functions are the same as those of thermal-mechanical stack relays, CAD cell primary controls offer a much quicker reaction time through visual as opposed to thermal flame detection, and greatly improved safety timing, drastically reduced from the 70 to 90 seconds typical of stack relays to 45 seconds with the most popular early versions of CAD cell relays. Safety timings of 15 and 30 seconds are also available with these first-generation controls, with 15-second safety timing being the norm for burners with higher firing rates. The only downside of these first-generation CAD cell primary controls is that most of them provide intermittent duty ignition only. CAD cell relays are typically mounted on a junction box attached to the burner housing, but most can be mounted in any convenient location on the burner, furnace, or a nearby wall. Among the controls currently operating in the field, there are minimal differences in CAD cell resistance operating ranges. Normally, the resistance is less than 1,500 to 1,600 ohms. Most also have similar upper operating temperature limits of 130 to 140 degrees Fahrenheit. But there are significant differences in lower operating temperature limits among various models, ranging from minus 40 degrees to plus 32 degrees Fahrenheit. This is just another in a long list of reasons why the good technician always double-checks installation instructions and manufacturer's recommendations, even while working on familiar equipment. The CAD cell primary control circuit is made up of two distinct interrelated components, the flame detector and the primary control.
Let's look at how CAD cell relays detect the presence and absence of flame.
The flame detector consists of a CAD cell, a holder to secure it in place, and a wiring harness to connect it to the FF terminals of the primary control. The CAD cell is a ceramic disc coated with cadmium sulfide and overlaid with a conductive grid. Electrodes attached to the ceramic disc transmit an electrical signal to the primary control. In darkness, cadmium sulfide has a very high resistance to the passage of electrical current. In visible light, its resistance is low and current is allowed to pass. For a CAD cell relay to start the burner, the flame detector must sense the absence of light or flame and therefore resist the passage of current through the FF circuit. Once the burner starts and flame is established, the cell senses light, resistance drops, current passes through the FF circuit, and the safety switch heater drops out, allowing the burner to continue to run. If the cell does not sense enough light on startup, the burner will shut off on safety in 15 to 45 seconds, depending on the control, and cannot be started again until the safety switch is manually reset. If the flame is lost during the running cycle, the very early model controls will shut the system down on safety within 15 to 45 seconds. Later models will make one attempt to restart. The detector is installed in the air tube of the oil burner where it can view the flame. The location of the CAD cell is determined by the burner manufacturer. If for some reason an alternate location must be used, make sure that the cell has a clear view of the flame. Ambient light does not reach the cell. Ambient temperature is below the cell's rating of approximately 140 degrees Fahrenheit, and that movement, shielding, or radiation of metal surfaces near the cell do not affect cell function.
As with stack-mounted primary controls, the major manufacturers adopted uniform standards regarding wiring connections for first-generation CAD cell primary controls.
In place of the numbered screw terminals on stack relays, CAD cell relays have color-coded wire leads pre-attached to the solid-state circuitry. These leads protrude from the bottom of the control. They're connected to the wiring from the system components, typically with wire nuts, inside the junction box that the control is mounted to. The hot wire from the limit control is connected to the black wire of the CAD cell relay. The white wire is connected to the neutral lead, along with the other neutral leads from the burner components. The hot wire of the burner motor, the transformer, and the oil valve, if present, are connected to the orange wire. The low-voltage side of CAD cell relays typically has two terminals labeled TT, which are normally connected to the thermostat. The CAD cell flame detector leads are threaded through a hole on the bottom of the low-voltage strip and connected to the FF terminals.
Now we'll explain how CAD cell relays function.
The most common first-generation CAD cell primary controls you're likely to come across in the field are the Honeywell R8184G or the White Rogers 668, both featuring intermittent duty ignition. They both operate as follows. If all components are functioning properly, the control is in standby mode until power is applied through the limit control to the black wire, and a call for heat from the thermostat completes the circuit between T and T. Then, assuming that the CAD cell does not sense light, the control is energized and the orange wire is powered. The transformer will generate ignition through the electrodes and the motor turns the fuel pump and burner fan. If there's an oil valve installed, it opens based on its delay timing. Flame is established and the CAD cell resistance decreases to fewer than 1600 ohms, de-energizing the safety switch heater and preventing the unit from shutting off on safety. As long as the CAD cell senses flame, the oil burner continues to run until either the thermostat or limit control is satisfied.
Let's verify safety functions.
To check the safety, turn off the electrical supply. Install a jumper across the FF terminals to reduce resistance and simulate flame. It's okay to leave the CAD cell leads hooked up. Turn on the electrical supply and make sure that both the line and low voltage circuits are complete. The control should not energize because shorting the FF terminal simulates a fire in the chamber. If it does energize, replace the control. If it doesn't, turn off the electrical supply and remove the jumper. Disconnect one lead from the FF terminals. Turn on the electrical supply. The control should energize and the burner should lock out based on its safety timing. If the control does not go off on safety, replace it and be sure to check the timing on the new control. If the control does go off on safety, reconnect the lead to the F terminal and press the reset button. The safety is working properly. Like stack relays, many of these controls also have a push lever to manually put the control into safety lockout.
Here are some troubleshooting tips. Let's assume that the oil burner won't start. First, speak with the customer. Verify that all switches are in the on position and that the thermostat is properly set. Be sure there isn't a fire burning in the unit.
Then, remove the cover and visually check to see if the spring-loaded mechanism has shut off on safety. If the primary control is not off on safety, check for proper voltage coming from the limit control. If there is sufficient line voltage, remove one lead from the FF terminals. If the burner starts, the problem is in the CAD cell sensor or wires. The cell may be sensing light or the wires may have been shorted. CAD cell resistance looking into an inactive chamber should be at least 50,000 ohms. If the burner doesn't start, disconnect all the thermostat leads and install a jumper. Remember, leaving the thermostat wiring connected to the control while testing may harm today's computerized thermostats. If the primary starts the burner, the problem is in the low voltage circuit. If the primary is off on safety, check the combustion chamber to be sure the unit isn't saturated with oil. This can't be overemphasized. If the chamber contains excess oil, follow your company's procedures to eliminate the oil. Never attempt to fire an oil burner into a chamber saturated with oil. If the chamber is free of excess oil, press the reset button. If the primary control energizes but the burner motor doesn't spin, turn off the electrical supply and check the electrical connections and the burner motor reset button. If the motor is off in overload, be aware that a bound fuel pump is often the culprit. Your job as a service professional is to find out why the pump has bound up. If the burner runs and flame is established but the control shuts off on safety, disconnect the CAD cell leads, press the reset, and before the unit shuts off on safety again, place a 1000 ohm resistor across the FF terminals. If the burner continues to operate with the resistor in place, the CAD cell relay is operating as designed, and the problem is with the CAD cell flame detector. With the unit operating, connect the CAD cell leads to your ohm meter. A reading of 0 ohms indicates a short circuit. Check for pinched or shorted CAD cell wires. If the resistance is infinite, check for broken CAD cell wires or a loose or defective cell. On most properly adjusted burners, you'll find the reading to be 400 ohms or less. Some burners with large static plates or small openings in the retention head operate in the 400 to 800 ohm range. Very few systems operate with resistance over 800 ohms. If the reading is greater than 1600 ohms, there's a serious problem with the fire, the CAD cell eye, its holder, its leads, its alignment, or its ability to see the flame. Remember, the CAD cell needs to have a good view through the air tube to the fire. If the eye is coated with soot, it will not be able to see the flame. Clean the eye and continue your troubleshooting to find out why the eye is getting dirty.
Second-generation CAD cell primary controls.
Second-generation CAD cell primary controls have the same basic features as the early models just described. But steady advances in technology led to a number of improvements. Many of these aren't readily noticeable because they're integral to the printed circuit board, but some of the enhancements resulted in significant differences. For example, second-generation CAD cell primary controls have electronic reset mechanisms, which are not spring-loaded. The reset button on these controls doesn't pop up when the unit shuts off on safety, and the reset doesn't have a thermal component, so there's no cooling time required before the control can be reset. To bring the control out of safety, you simply depress the reset button for 3 seconds. The Carlin 48245 CAD cell primary control incorporates a red LED lockout indicator that lights when the unit goes off on safety. And the Carlin 40200 and 42230 controls offer 15 and 30-second safety timing respectively, a safety monitoring circuit, interrupted duty ignition, and a recycle on flame failure feature.
The safety monitoring circuit addresses the biggest weakness of miniature relay CAD cell primary controls: welded motor contacts.
This circuit monitors the contacts of 2 separate motor relays. Safety lockout occurs if the contacts of either motor relay are found closed when they should be open, ensuring shutdown even if one motor relay fails.
Interrupted duty ignition.
The Carlin 40200 and 42230 interrupted duty ignition CAD cell primaries have an additional blue wire, which is connected to the transformer or igniter. As we've learned over the years, interrupted duty ignition is much better than intermittent duty ignition. With interrupted duty ignition, electrodes and igniters or transformers last longer. Electrical consumption, operational noise, and NOx emissions are reduced, and combustion problems leading to dirty boilers and running saturations are minimized.
Recycle on flame failure.
Recycle on flame failure means that instead of shutting off on safety, if flame is lost during the run cycle, the burner will shut off within approximately 1.5 seconds. After a wait of 60 to 90 seconds, the control will attempt to restart the oil burner.
Second-generation interrupted ignition CAD cell primary controls operate similarly to first-generation controls.
If all components are functioning properly, the control is in standby mode until power is applied through the limit control to the black wire, and the circuit between T and T is closed. Then, assuming that the CAD cell does not sense light, The control is energized and the blue and orange wires are powered. The ignition and motor start. After the CAD cell senses flame, the ignition stays on for another 10 seconds, then shuts off. As long as the CAD cell senses flame, the oil burner continues to run until either the thermostat or limit control is satisfied. If the control does not sense flame within the control safety timing, lockout occurs. Pressing the reset button for 3 seconds resets the control. As you've seen, primary controls have changed greatly from the days when stack relays were the state of the art. Keep in mind that better flame detection, faster response to flame failure, safety monitoring circuits, and interrupted duty ignition are just the beginning. Primary controls continue to evolve, and the controls available today offer noteworthy advantages for both the service technician and the homeowner. Significant, measurable, cost-effective operational improvements have come with the addition of a small microprocessor in the printed circuit boards of the latest CAD cell primary controls. In addition to standard interrupted duty ignition, 15-second safety timings, and functions similar to pre-purge and post-purge, current state-of-the-art controls offer dry alarm contacts, protection against excessive resetting, a limited recycle feature, and diagnostic LEDs which simplify troubleshooting.
These new Carlin and Honeywell controls will be featured along with Riello controls in the third video of this set, NORA Ed V7.